Hello, Mario. In this instructional video, I'm going to take you through the solution of this cubic graph here. I attempted this just at the end of class on Friday, and well, it didn't go so well. I had a bit of a nightmare, and things got a little bit confusing. I did get the answer in the end, however, it was a little bit mixed as to how we got there. So I thought I'd get all my thoughts down clearly and record them in this video. So here we go. So yeah, here's the problem stated. It's told us that it's a cubic graph. So that means it will have a x cubed factor in it, and it should have three factors, or three factors, or sort of three solutions or places where it will cross the x-axis. Potentially, and we can see that this one does cross the x-axis in three places. So if we bring into the factor the standard equation, y equals k, x minus a, x minus b, x minus c, not the only standard equation, but one form of it for the cubic, where a, b, and c are the x-intercepts. So a is -1, b 0, and c is 1. So let's put them into the equation. And there we get y equals k, x minus -1, x minus 0, and x minus 1. So we can see there the x minus -1 will become a plus, and the 0 is unnecessary, so we can remove that, and it doesn't need to be in brackets, so we can write it like this: y equals k, x plus 1, x minus 1. Now I look for patterns and things in these, and I can see a pattern there, x plus 1, x minus 1, and that is the sort of pattern for what we call a square minus a square, or the difference of two squares. And so, in my wisdom or not, you're able to write the equation as y equals k, x squared minus 1. Okay, so that's all well and good. And then we could maybe expand that out a little bit, and we get y equals k, x cubed minus x, like so. And I said, okay, well, let's have a look at the point -5, 0.75. That's the point on the graph. So that would enable us to substitute that in and determine what k is. Now, I saw a pattern here, and I thought, well, -0.5, negative, and 0.75, it could get a bit tricky, but that's a -1/2 and 3/4. Well, that might be slightly easier. And I sort of trying to second guess the examiner or here, and maybe I overthink it. But anyway, I thought, oh, well, that looks like the way to go. So away I went, and I fed it in. So we get y 3/4 equals k, -1/2 cubed. I couldn't quite get that big bracket there between the thing, but anyway, -1/2 cubed minus -1/2, because remember that the x is -1/2. So put that into the equation and do the cube really. K equals -1/8. So 1 cubed is 1 and 2 cubed is 8. 1/8 plus 1/2. There. So all right. So I can do that fairly easy in my head. 1/2 is 4/8, and minus 1/8 is 3/8. So there we go. Oh, okay. So now we divide both sides by 3/8, and that's equal to k. 3/4 divided by 3/8 equals k. Run out of room there, so we'll rewrite it again here. And to divide, we change divide to multiply by the reciprocal. So 3/4 times 8 over 3 is k. K equals 24 over 12, which equals 2. So we could rewrite the equation in this form here, and that's our answer. Many forms of the equation would be acceptable. Now, when we looked at the model answers for the question, they had done it slightly differently. So an alternative method and using decimals. So I thought swapping to fractions would be, the move, a very good move. And, well, as it turns out on the day, perhaps it wasn't. But you can see it's relatively simple here now that I've had some time to put it all together and formulate it. So then we look at negative 0.5 and 0.75, and we substitute them into, or here's our equation, and we substitute them in at this point here rather than simplifying it further, and we get 0.75 equals k minus 0.5 there, because x is minus 0.5, and then minus 0.5 plus 1, the first bracket, and minus 0.5 minus 1, the second bracket. Okay, now pulling all that together, we get 0.75 equals k, negative 0.5, 0.5 minus 1.5. So negative 0.5 times 0.5 is negative 0.25, times 1.5 is negative 0.375, or 3/8. And so we divide both sides by by 0.375, not negative, and that equals 2. And so there's the equation. We could write the equation like that. That would probably be acceptable. We could simplify it like that using the square minus the square, or difference of two squares pattern, or then we could fully expand it out sort of like that there, and voila, we end up at the same place. So as long as what you do is right, you should end up in the same place. But the problem I had on Friday was that I left off a negative sign and put something in the wrong place, and yeah, it didn't quite go as smoothly. So there you are. I think that's a fairly smooth sort of explanation of that problem, giving you a couple of alternatives and perhaps helping to clarify the situation. All good. Cheers. See you.